This video is starting on 561. We're working on Module 4, Topic 2, Lesson 1. We're going to be going over Activity 3 and 4, and then assigning our assignment at the end. So starting with 561, this Activity 3 is determining the length of the hypotenuse. We're going to first start with this problem where we have two worked examples. So it talks about Evan and Sophie's calculation to determine a triangle, determining the hypotenuse, which is the value c. So like when we have a right triangle like this, the side opposite the right angle, that's the hypotenuse right there. Okay, so what is that value? How long is that side if we don't know what it is? So we plugged in. Right, it looks like we know that the Pythagorean theorem is a squared plus b squared is equal to c squared. They're just setting it up in a different way. C squared is equal to, right, the sum of the two legs, a squared and b squared, and Sophie's doing the same thing. But number one, it says, explain the algebraic error in Evan's work. So Evan does something wrong versus Sophie. So looking at Sophie, she squared 2 to get 4, squared 4 to get 16, added that to get 20, and then at this step, took the square root of both sides, which is good. The square and the square root undo each other, right? We have c equal to, and then when you take the square root of 20 and round it, it's about 4.5. Now here, something else happens. In this case, what Evan did is he added the 2 and the 4, right? He added that to get 6, and then squared, took the square root of both sides, and we know that the square undoes the square root. We're left with just our radicand of 6. So that does not work out. So in this case, we are supposed to square the numbers and then add. Evan, though, did not, we're going to say did not follow order of operations. But I'm just going to put he did not follow order of operations, which is GEMDAS. He was supposed to use the exponent first before adding, where he added before he did the exponent. Okay, next one, number 2. It says use the Pythagorean theorem to help Mitch with some of his problems. So we have pretty much all these are going to have some type of context, either visual or word based. But this one is still working within finding the hypotenuse. So for number 2, it says Mitch needs to wash the windows on the second floor of a building. He knows that the windows are 12 feet above the ground. Because of dense shrubbery, he has to put the base of the ladder 5 feet from the building. So he's got to go a little bit further out. What ladder length does he need? So how long does that ladder need? Maybe it's a ladder that like extends. But my recommendation whenever you start any problem like this, always write down the formula and plug in what we know. Now, in the visual image, we need to always find the right angle. The right angle is right here. We know that the sides that are right next to it, this and this, are the legs of the right triangle. And the side that is opposite is the hypotenuse. Okay, so the hypotenuse is always the value of c. So we don't know what c is yet. That's what we're trying to find for this problem. So let's go and plug in. We could plug in 5 either for a or b. I'll do it for a. We'll plug in 12 for b. And then c, we don't know what it is. I'll just keep it as c squared. This is 25. This is 144. This is c squared. Combining these two terms, that's going to be equal to 169 equal to c squared. And when you get to this step, right, how do you solve the equation? You need to get c by itself. Now, normally we always perform inverse operations. The inverse of a square is taking the square root of both sides. Right, a square undoes a square root, so I cross those two things off. The right side we just have c. The left side we have to figure out what is the square root of 169, and this is a perfect square. So if I go to this, our list of squares or square roots. Well, this is from 1 through 10. But if we keep going here, right, square root of 121 is 11. Then the next one is 144 is 12. Square root of 169 is 13. But if you take this and plug this into a calculator, square root of 169 is 13, right? We don't have to round it all. So let's put 13. Okay, so to answer the question, right, how long does the ladder need to be? It needs to be 13, and make sure that we put our units, 13 feet long. Right, for him to reach the second floor of that building to wash the windows. Okay, moving on to the next problem. We're just going to work on number 3 and skip 4. But whenever we have a context like this, it's important to have some type of image. So when the image is created for us, let's use that and annotate on it. So number 3 says, Miss Fisher asked Mitch to put up a badminton net. She wants the top of the net 5 feet above. That's what we have here. And she tells Mitch to place the stakes of the rope supports 6 feet from the base of the poles, so right here. And Mitch has 2 pieces of rope, one that is 7 feet and a second that is 8 feet. Will these be enough to secure badminton poles? Okay. All right, so we do have to answer that question. But first of all, right, we have the right angle here. So we know that this, we could put X, but I'm going to still keep it as C. We'll say that this is A and this is B. All right, so as always, before we start a problem, we're going to put the formula for the Pythagorean theorem. All right, we're going to plug in 6 for C, 5 for B, and we'll keep this as C squared. 6 squared means 6 times 6, that's 36. 5 squared is 5 times 5, which is, 25. And then we have to combine these two like terms. Where that added together is 61, equal to C squared. And then from there, taking the square root of both sides, or the square undoes the square root, we're left with C, that's what we want. And the square root of 61 is not a perfect square, so we're going to plug this into our calculator. I'll put 61 and I'll hit the square root button. It's 7.81. Whoops. It continues forever. It's irrational. But let's go and round this to 7.81. Whenever we round, we should put approximately equal to 781 hundredths. Okay. So for this is, we would need a rope that is 781th or 81st or 8100th of a foot. So foot rope. Right, so going back to the question, will this be enough to secure the badminton poles? The 7-foot rope will be too short, but we'll say that the 8-foot rope works for this. Okay. So there, right, not enough just to calculate it, but also answer the question. We're going to skip number 4 and go to the next lesson. Or sorry, next lesson, next page. We're going to go through 2 more examples here, 5 and 7. So let's go through 5. 5 looks like we're at a skate park. So they will replace the skate ramp on the playground of a neighboring park. Mitch needs to determine how long the ramp is to get estimates on the cost of a new skate park. He knows the measurements shown in the figure, so he probably measured the width, measured the height. How long is the existing skate ramp? Okay, so for this we know, right, 15 and 8. We do not know the hypotenuse, which is C. All right, so this is going to be 8 squared plus 15 squared equal to C squared. We're going to have 64 plus 15 times 15 is 225. And if we add these two values, it should be equal to 289, equal to C squared. Square undoes square roots. We're left with C, and square root of 289. Let's plug that into our calculator. 289 square root is 17. Okay, whoops. All right, so C is equal to 17, so this is going to be 7. The skate ramp is going to be 17 feet long. Okay. And moving on to number 7. 7, we are computing the right Pythagorean theorem formula, but also answering a question of will it fit in this kind of confined space. So it says the school's new industrial size refrigerator is 7 feet tall and 5 feet wide. The refrigerator lies on its side. Mitch and the movers want to tilt the refrigerator in order for it to fit, but they worry about the refrigerator might hit the 8-foot ceiling. So that's something that we're going to have to keep in mind at the end. Will the refrigerator hit the ceiling when they tilt it upright like this? So things that we're going to have to annotate here, right? We don't have a triangle, at least not now. But we want to know, will it clear this, which is 8 feet? Otherwise, it's going to hit the ceiling. I mean, visually it doesn't seem like it now, but that's why we have to calculate it. I'm going to take this top part and, right, the part at the ground. We're going to draw this line here. I'm just going to trace this part. We're going to use, right, there's kind of 2 triangles that are formed here. One by this guy, one by the girl. I'm just going to use this one here. So this one is 5 feet wide. And even though we don't have a number here, we know that it's 7 feet long from here. This is a right angle. We want to figure out what this is, if that's less than or more than, greater than 8 feet. So we're going to use 5 and 7 for the legs of our right triangle. So we're going to have 5 squared plus 7 squared is equal to c squared. All right, we're still going to have 25. 7 squared is 49. This is equal to c squared. If we add this together, it's 74. Final step, always take the square root. And square root is 74. Right, what times what is equal to 74? 8.6. So if we multiply 8.6 times 8.6, right, that's really close to 74. So let's put that here, 8.6. Right, so this is 8. If we were to tilt this, it would be 8.6 feet tall. So looking at our question here, right, will it hit the ceiling? Well, the ceiling is only 8 feet. So because it's only 8 feet tall, the fridge will hit the ceiling. Okay. All right, and then from there, we're going to move on to activity 4. Only a couple examples, not as much as the last one, but we worked on trying to find the hypotenuse, and typically this is a little bit easier than compared to when you're trying to find the leg. Right, so when we talk about the leg, if we have 2 right triangles, the legs are A or B. So in this case, we're actually given C, we're actually given the hypotenuse. So it says write an equation to determine the unknown value. We're going to round to the nearest tens place. This first one, we're only going to work on A, and then we'll do a couple others on the other page. Let's look at A. So, right, since we have the right angle here, we know that C is 11. Now, just kind of a hint here, we know that the hypotenuse should always be the longest side, meaning it'll always be the biggest number. So since the biggest number is 11, this number can never be bigger than 11. So if you calculate something, you get something bigger than 11, it wouldn't work out, okay? Maybe we made a mistake. Let's put that this is A, this is B. We could switch it. We could say that 9 is B and X is A. Doesn't matter, right? Legs are interchangeable. But let's plug in our formula. So we're going to have 9 squared plus X squared equal to 11 squared. We're going to keep 81. Nothing happens with x squared. And 11 times 11 is 121. Now here, we have to isolate x squared. So this 81 here, that's a positive. We're going to subtract 81 to both sides. We get x squared equal to, if you subtract this, you're going to get 40. And our final answer is going to be whatever the square root of 40 is. So x is, we are going to have to round. Because, right, square root of 40 is not a perfect square. Like square root of 36 is 6. Square Square root of 49 is 7. So it's going to be somewhere between 6 and 7. So let's plug this into our calculator. 40 square root. So round to the nearest tens place, we would look at 6.3. We look at the 2 in the hundreds place to tell us around. Since it's smaller than 5, that tells us to stay. So it's going to be 6.3 as our final answer. All right. We didn't worry about units at all, so we don't know if this is like feet, inches, centimeters. So we're just going to keep that. Okay. And then let's go and move on to our last page. So 565. But you're welcome to use any one of these 3 problems as examples. Now, it's these types of problems where it's just only words that I would recommend always draw an image. Always draw an example, because I know a lot of students are visual learners, and when we don't have that visual, sometimes it's harder to determine like where do these numbers go in this situation. Anyways, so let's read this carefully. Sandra has a ladder that is 20 feet long. When the top of the ladder reaches 16 feet up the side of the building, how far from the building is the ladder's base? Okay. Right, so for me, I like to draw an image. So I'm going to draw a building. Let's say this. We'll draw like a ground too. The ladder is going to go, the ladder is, I'm going to say this is the ladder here. This is 20 feet tall from here. We say that when we lean this up against the building, it's going to reach 16 feet up that building, right? So that's this distance right here. But we don't know what is this distance. Now here, there's a right angle that's formed in this triangle that's right here. This tells us that 20 is the hypotenuse, 16 is a leg, and we don't know what the other leg is. Okay. Maybe I'll draw a ladder here. Something like that. So when we plug this for a squared plus b squared is equal to c squared, we know that 20 is going to be for c squared. Sometimes I see students plug in 20 for a or b, but that's not a leg. We could put 16 for a. We could put question mark for b, but I'll keep it as just b squared. 16 squared. 16 times 16 is 265. 20 squared, 20 times 20 is 400. And if we subtract 256 to both sides, let's subtract this. I can't take away 6 from 0, but I can borrow, not from the 0, maybe from the 40. This will become a 39 if I take 1 from it. So I take 1 tens and I make this into 10 ones. 10 minus 6 is 4. And then 39 minus 25, I'll do that together, is 144. And maybe this is familiar because if you take the square root of both sides, we get b squared equal to, the square root of 144 is a perfect square. Let's look right here. Square root of 144 is 12. Okay, so in our unit, it's got to be 12 feet from the base of the building. That's how far that ladder is going to be. Okay, so this was a nice number. We got a whole number. Next one, we're not going to get as nice of a number. But let's look at this situation. So it says the length of a hypotenuse of a right triangle. So let's just draw a right triangle. This may not be exactly representative of the situation, but we have something like this. The hypotenuse is 40, so this will be 40. The legs of the triangle are the same length. I'm gonna put a tick mark here and a tick mark here. I'm gonna put, I'll put X and X. These are the same exact thing, so I'm putting the same variable then. How long is each leg of the triangle? Okay, so we actually don't know both of them, but we at least know that they're the same. So similar process, slightly different though in how we simplify it, but we can still go about this. We know that C is going to be 40, and that A and B, they're both X's. X squared plus X squared. Okay. Now you can think about this as like 1x squared and 1x squared. So these two things are actually like terms. 1x squared plus 1x squared. We could think about it as just like 1 banana plus 1 banana. That's 2 bananas. Or just 2 x squared. Okay. Now to simplify this, you do have to do 2 steps to this x. We have to get rid of the 2, and we also have to get rid of the square. Right, typically go in reverse order of operations when you're solving an equation. We have to get rid of multiplying. So we're going to divide both sides. Oh no, you know what? First I need to actually square. I didn't square this. 40 times 40 is 1600. Now here we go. Okay, now we're actually going to divide both sides by 2. We'll get x squared equal to 800. When we take the square root of both sides, we're going to find what our answer is. This won't be a whole number though, because square root of 400 or 800, right? We got to figure out what times itself will give us 800. Square root of 800 is 28 point something. If we round to the tens place, this 8 in the hundreds place will tell that 2 to go up. Right, 5 or more. Raise one more. So this will be 28.3. 28.3. It doesn't give us does it give us a unit there? Oh, centimeters. So that's how long the legs are. 28.3 centimeters when the hypotenuse is 40 centimeters. Okay. Anyways, we're not going to work out 4 and 5. It's more of you-dos or additional practice if you feel like you need it. We're skipping all this other stuff. This was for the previous activity, but our assignment. Our assignment is on 569. We're going through everything on the front and on the back side in regards of practice. So that's number 1, all 2, 3, and then we have 4, 5, and 6 on the back side. We're just not doing stretch. So numbers 1 through 6. All right, let's go and get started.